All right, so our standard we're looking at here is solving linear systems again, but instead of graphing this time, we're going to use what's called substitution. Okay, so kind of walk you through the steps, and then we'll try some practice problems here together. So, substitution essentially means you're going to solve one of the equations for one of its variables. When possible, solve for a variable that has a coefficient of 1 or -1, just because they're easier to work with. So you can see in our first in the example here, right, our first equation, right, notice that first one is solved for y, okay? You could solve for x as well, but this one's presented as y, so we just want to solve for one of the variables. All right, step 2 then is to substitute the expression from step 1 into the other equation and solve for the other variable, right? So we know what y is equal to, right? And in math, when two things are equal to each other, we can substitute them for each other. Okay, so notice that in our second example, we took our 6x plus 2y equals 30, and we essentially removed the y, right, and replaced it with what the y is equal to, in this case 4x plus 1, and you can see that in the equation there, right? So this is that second equation, 6x plus 2y, except for y, we get rid of that and put in what y is equal to again. Since they're equal to each other, we can substitute them, okay? And again, we want to put that in parentheses because we got to multiply 2 times that whole thing, okay? Now, what that does is it doesn't have a y in there anymore, so now we can solve that equation for x, all right? So you'll notice in the next step, we just did distributive property there. 2 times 4x is 8x, 2 times 1 is 2. Added the 6x and the 8x to get 14x. Move the 2 over with subtraction, 30 minus 2, okay, to get rid of that. So 14x is 28, and then divide by 14 to get x is equal to 2, okay? So we know our x value, right? Since we know our x value, we can then go in and solve for our y value, okay? So substitute the value from step 2 into the arises equation from step 1 above. And honestly, it doesn't matter which equation you use. We use the second one here, but since I know the x value is 2, right, you can, again, we got 6x plus 2y equals 30, right? You notice here we substituted 2 in for x, so replace the x with 2, okay? So we got 6 times 2 plus 2y equals 30. 6 times 2 is 12, right? We moved subtracted the 12 from both sides, and we're just to a 2-step equation here. So 2y is 18, and then divide by 2. Y is 9, okay? So our solution, again, solution is a coordinate pair, so our x value is 2, and our y value is, we just solved those 9, so that would be my answer, okay? So rather than graphing them and seeing where those two lines intersect, we're going to solve for one of the variables and then substitute. All right, let's look at a couple examples here. So again, if you want to solve it, pause the video, solve it, and come back, see how you did here. All right. So in the first example, we know what y is equal to 3x plus 2. Okay. So I'm just going to take out my y, and I'm going to replace it with 3x plus 2. Again, we want to put in parentheses because it's that entire thing. Okay. And I just want to solve that. So distribute. So that's 6x plus 4. Okay, which makes it 7x equals 11. So that's 7x plus 4 equals 11. Right, if I take away 4 from both sides, I'd have 7x equals 7, and x would be equal to 1. Okay, oops, there you go. All right, it's pretty simple. Again, I know what my y is. It tells me y is 3x plus 2, so I take my y value, or I take my y, replace it with 3x plus 2 since they're equal to each other. Now that I know my x, I can solve for y. Okay, so I'm going to show you both ways. So I'm going to use the second one here. So I'm going to use the second one to figure out what y is, and then the next one I'll show you how to use the other one. Okay, so x I'm going to replace with 1. 1 plus 2y equals 11. Okay, take away 1 from both sides, 2y would equal 10. Divide both sides by 2, y would equal 5. Okay, so I know my x value, my y value, so my solution would be 1, comma 5. Again, we want to write our solution as an ordered pair. Okay. All right, now for your second equation, you can go ahead and pause it, try it on your own first. Okay. We got y equals 2x plus 5. 3x plus y equals 10. So again, I know what the y value is already. So I'm going to take out the y value, take out y, and put in 2x plus 5. Since they're equal, I can substitute. Okay. And this one is just 1y, so I don't need to multiply anything out. So combine my like terms, 3x and 2x is 5x. Okay. If I take away 5 from both sides, I'd have 5x equals 5. Divide both sides by 5, I'd get x is equal to 1. Okay. Give myself a little space here. Again, this stuff takes some room, so make sure if you don't have space on your worksheet or whatever, use a separate sheet of paper. Okay, now I'm going to use this one this time, just to kind of show you how easy that can be. So y is equal to 2 times 1 plus 5. Again, that's probably do both those steps in your head. 2 times 1 is 2. 2 plus 5 is 7. Okay, so I got my x value, my y value. So I get 1 comma 7. Okay, so we're just substituting, solving, plugging that solution back in to solve for the other variable, right? All right, so now we're going to look at a problem where, in this case, it's solved for x, okay? The previous two, they were solved for y. Here we have one that is solved for x. So it doesn't really change much. It just, sometimes when things look different, that kind of throws us off a little bit. So we're going to look at what we do on this particular one, okay? Now, if we think about what we did on the previous ones, right, I knew what y was, so I substituted my value in for that. So I know what x is in this case. I know x is equal to negative 2y minus 6. So I'm just going to substitute that into my first one, okay? So x minus y equals 3. So negative 2y minus 6 goes in where x is, minus y equals 3. Okay, combine like terms, negative 2y minus 1y is negative 3y minus 6. Add 6 to both sides to get 9. Divide both sides by negative 3. Right, so I know my y value is negative 3. Okay. Now I can solve my x value. Right, it doesn't matter which one you picked. We saw that with the previous problems. Okay, so I'm just going to pick my first one, x minus my y value of negative 3. So x minus negative 3 equals 3. Right, that substitutes in there for, so x minus negative 3 changes to x plus 3 equals 3. If I subtract 3 from both sides, I get x is equal to 0. X is equal to 0. Okay. So then I got 0, comma, negative 3. And again, we can check those, right? X minus y equals 3. So 0 minus negative 3 is positive 3. It works there. X equals negative 2 times y. Well, negative 2 times negative 3 is positive 6. 6 minus 6 is 0, which is our x value. So it checks out there. Okay, so we know we're right. Okay, if we flip the page here, we got some more examples. Right now on these are not in slope-intercept form. So you're going to have to pick one and solve it for slope-intercept form, or solve for one of the variables. Doesn't necessarily have to be slope-intercept, I guess. You just need to solve it either for x or for y. And again, if you look for ones that have 1 as coefficients, that's usually kind of the quickest. So like in my first example here, okay, I've got a coefficient of 1 on the x, so I'm going to solve that for x here quick. And again, you can maybe do this mentally. But again, we just need to move the minus 2y over to the right side by adding 2y. Okay, so I've got x is equal to 2y minus 6. Okay. So now I know what x is equal to. I can substitute that in to my second one there. So 4 times x is 2y minus 6 plus 6y equals 4. So 8y minus 24 plus 6y equals 4. Right, combine like terms, 8y and 6y make 14y minus 24 equals 4. Right, I'm going to add 24 to both sides, so 14y is 28. Divide both by 14, y is equal to 2. Excuse me. Okay, I get y is equal to 2. All right, now that I know what y is, I can solve for x. There's a full room here. Okay. So I'm going to take the first one. So x minus 2 times 2, since that's my y value, equals negative 6. X minus 4 equals negative 6. Add 4 to both sides. X would be negative 2. Okay, so my solution would be negative 2, comma 2. Good. And again, we could check those. Negative 2 minus 2 times 2 is 4. Negative 2 minus 4 is negative 6. 4 times negative 2 is negative 8. 6 times 2 is 12. Negative 8 plus 12 is positive 4. So it works in both equations. Okay. Second one there. I'm just going to move the 3x to the other side on this. So I'd end up with y equals negative 3x minus 7. Okay, again, if you can find that coefficient of 1, you don't have to do any division. So it just saves you a step. So I could solve the second one for y or solve for x as well. But if you can find a coefficient of 1, right, that usually saves you a little bit of time here. So now I know what y is equal to. So I'm going to take my second equation, negative 2x plus 4. And my y value is negative 3x minus 7 equals 0. Okay, multiply that out. 4 times negative 3 is negative 12x, and 4 times negative 7 is negative 28. If I combine like terms, I have negative 14x minus 28 equals 0. Add 28 to both sides. Negative 14x is 28. Divide both by negative 14, x would be negative 2. Okay, so I'd have my x value. X is negative 2. So a little bit of room here. And I'd highly recommend you use a separate sheet of paper because these take some work. Okay, and then I'm going to plug that in there. I'll take the first one. So 3 times negative 2 plus y equals negative 7. Again, I'm using this equation here. That's negative 6 plus y equals negative 7. Add 6 to both sides. Y would be negative 1. So negative 2, negative 1 would be my solution. Okay, negative 2, negative 1. All right. Let's try the third one here. Okay, again, think about which one would you solve for first. So you're looking for that coefficient of 1. So you got a coefficient of 2, negative 3, 2, positive 1. So we're going to solve this one for y. I think it's just a matter of moving the 2x to the right side with subtraction. So y would be equal to negative 2x plus 8. Okay. Take my first equation, 2x minus 3. Substitute my y with negative 2x plus 8. Equals 24 there. Okay, use your distributive property. Again, be a little careful. We've got a minus there, so that's negative 3. So negative 3 times negative 2 is positive 6x. Negative 3 times positive 8 is negative 24. Okay, combine like terms there. 2x and 6x is 8x minus 24 equals 24. Add 24 to both sides, so 8x would be 48. And divide both sides by 8, x would be equal to 6. Okay. And then we just want to solve for y, so I'm going to use this one again. So 2 times 6 plus y equals 8. 12 plus y equals 8. If I take away 12 from both sides, y would be 8 minus 12 is negative 4. Okay, so that would be my my solution there, 6 comma negative 4. All right. So again, doing the same thing. These are a little bit tougher because you first have to solve for one of the variables. Again, your key there is to see if you can find that variable with a coefficient of 1. Sometimes you're not going to have that, but a lot of times you will. So solve for that variable just because it's usually just one step to do that. Okay, and then again, once you know what one variable is, you can substitute in, solve for the other variable. Okay. All right, so our last thing we'll look at here is just, again, there's a little bit of review. We've talked a little bit about what this means when we graph. So we'll just kind of talk about what this stuff means again. A system of two linear equations can have one solution, no solution, or an infinite number of solutions, right? Remember, one solution means only one intersection point, one xy value that works, okay? No solution on our graph, we saw those are parallel lines. So that means there's no xy that would work, right? Same slope, right? Different y-intercept. Okay, an infinite number of solutions means that they're going to share all their xy values, right? So the one equation's xy values are the exact same as the other equation's xy values, all right? And how will you know if there's no solution, one solution, or an infinite number of solutions? Again, one solution, right? They're just different equations, right? The slope's different, the y-intercept's different. No solution means they have the same slope, right? So when you write it in slope-intercept form, right, y equals your slope, mx plus b, right? That's same m, okay? Same m, different b, okay? And then linear system with infinite amount of solutions, right, is going to be the same equation, okay? Same equation. Right. So if we're going to talk about examples, right, get an example of a linear system with one solution, right? All of our previous ones we've done have been one solution, right? Y equals 2x plus 4, y equals x minus 3, right? They're just different. They have different slopes, different y-intercepts. Give an example of a linear system with no solutions. That's going to be parallel. So like y equals 1 half x minus 2, y equals 1 half x plus 4. An example of a linear system with an infinite number of solutions, again, that's going to be the same. And sometimes they might look different, like x plus y equals 3. If I subtract the x, I'd have y equals 3 minus x, right? So they look a little different, but when you solve them, you're going to get the same thing, okay? All right. Now, last thing here, okay, because since we're not graphing it, right, we might want to look at what kind of these things look like when you solve them, right? So these, like I said, these are, oops, there we go. These are exactly like the previous example problems we've looked at, right? You're going to have an x, solve for x, or solve for y, plug that in, solve for the other variable, right? This one, if I went through and solved this one, right? Y equals 1 half x minus 2, y equals 1 half x plus 4, right? What's going to happen if I substitute? So I know what y is equal to, right? Let me change this slightly, just so it might be more something you might see. So let's say we had y equals 2x plus 3, and then we had y minus 2x equals 5. Okay, so if I wanted to solve that, right, I would, I know what my y is equal to. So if I did my substitution, I'd end up with, and again, I'm going to take this one here and replace the y value. So my y value is 2x plus 3. Minus 2x equals 5. Okay. And if I combine those like terms, 2x minus 2x is nothing. So I'd end up with 3 equals 5, which is false. Okay. So when you're solving your linear system, if you end up with a false statement like that, okay, that means it's going to be no solution. Okay, and we saw that with equations stuff when we solved equations. So false statements, no solution, right? If I did the bottom one, if I solve that, so I know y equals 3 minus x. So if I go x plus, substitute my y with 3 minus x equals 3, right? X minus x is 0. I'd end up with 3 equals 3, which is true, right? So that'd have an infinite number of solutions, right? When we solved equations, we used all real numbers. So we're just going to say it's an infinite number of solutions there, right? So again, we don't have the visual of the graph. But again, when we solve the linear system, if we can solve it and come up with the x value and the y value, then it has one solution, right? If we end up with a false statement, okay, that's where it's no solution, right? That's false. And if we end up with a true statement like we did here, then there's an infinite number of solutions because it's going to be the same line. All right.